So in this section, we will be recognizing and differentiating between key terms in an experimental design. We will identify proper experimental design. And so our first topic is experimental design. So the purpose of an experiment is to investigate the relationship between two variables. Okay, so one of them being the explanatory variable, and that is the independent variable in the experiment. Okay, so independent variable. This variable causes change in another variable. Okay, so let's look at two simultaneous examples. Okay, so remember with variable in section 1.1, we have like a capital X or capital Y. So we're going to use that terminology as well. So let's say capital X, we're talking about a diet pill. And then for capital, for capital X, for a second example, we could use a fertilizer. Okay, so we're going to be looking at two different types of examples at the same time, just to give a little more reference. And so our second type of variable is a response variable. And so this type of variable is the dependent variable in experiment, and then it is measured for change at the end of the experiment. Okay, so for a diet pill, your response variable can be weight loss. So you're taking a weight loss pill. And so for fertilizer, your response variable can be growth in your roses. So you're trying to grow roses. Oops, sorry, I think I used the wrong color. Growth in roses. Okay, so those are our two variables in our experimental design. So let's keep going. So in the randomized experiment, the researcher manipulates values of the explanatory variable and measures the resulting changes in the response variable. Okay, so here are some new vocabulary in terms of like a randomized experiment. So let me highlight that. Okay, so treatments. Um, Treatments are the different values of the explanatory variable. Okay, so in terms of our example, what this could mean is different brands of diet pills. Different brands of diet pills. And in a rosebush experiment, this could be different brands of fertilizer. Okay, so those are treatments. So experimental unit is a subject, single object, or individual being measured. So in this case, this would be um, one patient, and would be one rosebush. Okay, just like oh, I wrote this in the wrong place. Give me 1 second. One patient and one rosebush. Okay, let me erase this. Okay, so those are experimental units. What are we, the single object or visual being measured? Okay, so let's look at a lurking variable. So a lurking variable is a variable that has an effect on a study, even though it is neither an explanatory variable nor a response variable. Okay, so it's just some type of variable that can affect the experiment or study. So what do I mean by that? So in terms of this diet pill experiment, weight loss experiment, it could be certain foods or it could be genetics. or it could be your mental health affecting some chemistry in your body. Okay, and then for our rosebush growth experiment, it could be like your weather. Or maybe it's raining, or maybe it's not raining, maybe it's really sunny, maybe it's cloudy. It could be where you place the plant, plant placement. Okay, so then lastly, uh, we have random assignment. And random assignment is organizing experimental units into treatment groups using random methods. And so what this really does is it's not relatively relating to these examples, but it is a method used to reduce any lurking variable. So anything that would affect the study um, negatively. Okay. So when a participation in a study prompts a physical response from a participant, it is difficult to isolate the effects of the explanatory variable. To counter the power of suggestion, researchers use the following items. Okay, so one is a control group, and a control group is a group that receives an inactive treatment. So an inactive treatment, but is otherwise managed exactly as the other group. Okay, so what essentially this is a group that does not get the treatment. It's just not getting the treatment at all. Okay, so placebo is the next term. I'm sure you guys have heard this throughout, here or there in your life, but placebo is an inactive treatment that has no effect on the explanatory variable. Okay, so, placebo, if you're familiar with it, you give one set of people the actual drug and you give other set of people like a sugar pill. We don't tell who got what, things like that. So the placebo would be the sugar pill, where it's not has no effect on the explanatory variable. And blinding is not telling the participant which treatment a subject is receiving. Okay, so you're blinding the participant in this case. So they don't know what they're receiving is related to this placebo bit, like they might not know they're getting a sugar pill. But okay, so double blinding next is where both the subject and the researcher um, are blinded in this case. So both the researcher and the participant, they both have no idea who got what sugar pill or diet pill. Okay. Um, so let's move on to an example and sort of put these new vocabularies to use. Okay, so example one, sort of a long paragraph. I'll read through it, but also you can read it in your head if you want. Um, so researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 men between the ages of 50 and 84 are recruited as participants. The men are divided randomly into two groups. One group will take the aspirin and the other group take a placebo. That could be like a sugar pill, like we were just saying. Each man takes one pill each day for 3 years, but he does not know whether he is taking an aspirin or the placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks. Okay, so the question is asking, identify the following values for the study. You want to find the population, sample, experimental units, explanatory variable, response variable, and treatments. Okay, so let's go one by one and divide up this this paragraph. Sorry. So okay, population. We'll go through that. What is our population? So um, what our population is we can see it through what the sample says. It says 400 men between the ages of 50 and 84. So we're using that sample, which we'll get into next, to represent all ages of men between 50 and 84. So that would be our population. So we would say all, which is a keyword, all men between the ages of 50 and 84. Okay, so then maybe I could highlight that. Okay, so then as we hinted to, our sample would be the same exact statement, but that 400 men we're talking about. So it would be 400 men between the ages of 50 and 84. Okay, so now our next one is we got population, sample, experimental units. Okay, so let's draw back to experimental units. Experimental unit is a single object or individual being measured. Okay, so now let's go find that in the statement. So experimental unit. Okay, so experimental unit would just be one man between the ages of 50 and 84. Okay, so next one is explanatory variable. Okay, so remember explanatory variable is your independent variable that causes change in another variable. Okay, so let's go find that. And what our explanatory variable would just be taking aspirin. Okay, that would just be that would just be our explanatory variable, taking aspirin. Because that's essentially what our experiment's about, is that taking aspirin reduces heart attacks. Okay, so taking aspirin regularly. Okay, and so response variable. Okay, so response variable is what is measured for change at the end of the experiment. Okay, so a response variable in this case would just be whether a subject had a heart attack. Meaning a man from 50 to 84 had a heart attack. Okay, so then last one is treatments. Okay, and our treatments here are just taking aspirin or taking a placebo. Okay, so aspirin or placebo. Okay, so that's pretty much it. Those are pretty much it for example one. We just labeled out all of these reading the paragraph. But okay, so let's move on to example two. Another long paragraph, so read through it if you want. I'll read through it as well. Example two says, the Smell and Taste Treatment and Research Foundation conducted a study to investigate whether smell can affect learning. Subjects completed mazes multiple times while wearing masks. They completed the pencil and paper mazes 3 times wearing floral scented masks and 3 times with unscented masks. Participants were assigned at random to wear the floral mask during the first 3 trials or during the last 3 trials. For each trial, researchers recorded the time it took to complete the maze and the subject's impression of the mask scent, positive, negative, or neutral. Okay, so part A wants us to describe the explanatory and response variables in the study. Okay, so um, the explanatory variable, remember that's our independent variable, the one that's causing change. So what that would be explanatory, I'll just short term it, explanatory variable. Um, that is just a mask with the floral scent. Okay. Because remember, explanatory variable is the variable that causes change in another variable. Okay. And that's the one thing being applied to the experiment is floral scented mask. And so our response variable, I'll abbreviate that as well. And then a response variable is what we're trying to see is measured at the end, the change. And so what that would be is the time it took to complete the maze in the subject's impression of the scent. Okay, so this question and like the other question, and much like these questions in general, the response variable will always sort of be like towards the end of the statement. So it'd be recorded the time it took to complete the maze and the subject's impression of the mask. Um, that's essentially what the experiment's about. So that's essentially what the response variable will be. It's just the outcome of the experiment, what's changing, what's being measured. But okay, so what are the treatments? Treatments are just the scented mask and the unscented mask. So scented mask and unscented mask. Okay. So on the next page, this example is continued. Okay, so identify any lurking variables that could interfere with this study. Um, so this is a tricky question. It's like opinion. It's kind of opinion based. So there are 2 options. So we could say 2 options. One being this is a random assignment, like as the question says. Random assignment. Yeah, random assigned at random. So we could say so random assignment. Random assignment eliminates any lurking variables. Or there's a second option that could be that maybe your patients that you have are very, excuse me, are very sensitive to the smell, or maybe at the time of the study they're sick, or maybe they're not good at mazes in general, or maybe it's allergy season, maybe they have allergies. So those are some lurking variables that you can have, but also like it is a random assignment, so random assignment in theory eliminates lurking variables, but it's just your opinion. So I'm gonna write down the second opinion, um, but it's really your option. Sensitive to smell, sick, not good at mazes, allergies, Okay, things like that. So part D is it possible to use blinding in the study? So your subject can be blinded. So subject can be blinded. I'm sorry, they can't be blinded. Excuse me. Uh, can't be blinded because they could smell the scent of the mask. Because they can smell the scent. Okay. And so the participants can be blinded, but the researcher can be blinded. Researcher could be blinded. They could not know what mask the participants are wearing. They could not know what mask participants are wearing. Okay, so that finishes example 2. But for the last leg of this 1.4 section about experimental design is about the sort of ethics that go into these studies. So ethics, when a statistical study uses human participants, the researchers should be mindful of the safety um, of the research subjects, and key protections that are mandated by law include the following. Um, Risk to participants must be minimized and reasonable with respect to projected benefits. Participants must give informed consent. This means that the risk of participation must be clearly explained to the subjects of the study, and data collected from individuals must be guarded carefully to protect their privacy. Okay, so let's look through examples and see what problems can rise in the ethics. So, example 3, describe the unethical behavior in each example and describe how it could impact the reliability of the resulting data, and explain how the problem could be corrected. Describe how it could be impact the reliability of the resulting data. Okay, so a couple things going on here. So it says a researcher is collecting data in community. So part A is she selects a block where she is comfortable walking because she knows many of the people living on the street. So that's she selects a block where she is comfortable walking. Okay, so that's not very good. So what we would say here is problem. This is convenience sampling. This is convenience sampling. Um, it's also a small sample, and it's maybe biased because she knows people and she's comfortable. Okay, so how would you fix this? You would randomly select blocks in the community and collect data. So randomly select blocks in the community and collect data. Okay. Um, so part B says no one seems to be home at 4 houses on a route. She does not record the addresses and does not return at a later time to try to find residents at home. Okay, so the problem here is you're missing data, and it could be biased. So actually not could be, it is biased, so biased. Okay, so how you fix this is you would go and return the collected data. return and collect data. And so within these types of data, you want to make every effort to interview all members of a targeted sample. You shouldn't leave anyone out. So yeah, that's how you fix that. But okay, so last one is C. And so say she skips 4 houses on her route because she was running late for an appointment. When she gets home, she fills in the forms by selecting random answers from other residents in the neighborhood. So here's a big problem here. This would be um, basically false data because she's inputting the data that, you know, that's not those 4 houses. False data. And then how you fix this is, you go over and return and collect data. And you just gotta make sure everyone's accounted for the designated sample you're choosing. And you can't input in data that isn't theirs. But okay, so that's section 1.4. We talked about the different types of experimental design, different types of variables, um, in the ethics of a experimental design. If you have any questions, you can reach out to me through email or come to my office hours, or rewatch the videos and see if anything makes more sense. But okay, so I'll see you guys in the next lecture video. Okay.